In the next few videos, we're going to spend some more time talking about the well-architected framework, because if you know how AWS recommends that you use their tools, then it's going to take you a long way when migrating your application into AWS or when developing with their tools. The AWS well-architected framework helps you understand the pros and cons of decisions you make while building systems on AWS. By using the framework, you will learn architectural best practices for designing and operating reliable, secure, efficient, and cost-effective systems in the cloud. It provides a way for you to consistently measure your architectures against best practices and identify areas for improvement. The process for reviewing an architecture is a constructive conversation about architectural decisions and is not an audit mechanism. AWS tools are built on the idea that having well-architected systems greatly increases the likelihood of business success. The well-architected framework documents a set of foundational questions that allow you to understand if a specific architecture aligns well with cloud best practices. The framework provides a consistent approach to evaluating systems against the qualities you would expect from modern cloud-based systems, and the remediation that would be required to achieve those qualities. As AWS continues to evolve and they continue to learn more from working with their customers, they'll continue to refine the definition of well-architected. The well-architected framework identifies a set of general design principles to facilitate good design in the cloud, and the first is that you should be able to eliminate guessing about your infrastructure capacity needs. When you make a capacity decision before you deploy a system, you might end up sitting on expensive idle resources or dealing with the performance implications of limited capacity. With cloud computing, these problems can go away. You can use as much or as little capacity as you need and scale up and down automatically. You should also test systems at production scale. So in the cloud, you can create a production scale test environment on demand, complete your testing, and then decommission the resources. Because you only pay for the test environment when it's running, you can simulate your live environment for a fraction of the cost of testing on premises. You should also automate to make architectural experimentation easier. Automation allows you to create and replicate your systems at low cost and avoid the expense of manual effort. You can track changes to your automation, audit the impact, and revert to previous parameters when necessary. You should also allow for evolutionary architectures. In a traditional environment, architectural decisions are often implemented as static, one-time events with a few major versions of a system during its lifetime. As a business and its context continue to change, these initial decisions might hinder the system's ability to deliver changing business requirements. In the cloud, the capability to automate and test on demand lowers the risk of impact from design changes. This allows systems to evolve over time so that the businesses can take advantage of innovations as a standard practice. You should also drive your architectures using data. In the cloud, you can collect data on how your architectural choices affect the behavior of your workload. This lets you make fact-based decisions on how to improve your workload. Your cloud infrastructure is code, so you can use that data to inform your architecture choices and improvements over time. And finally, you should test how your architecture and processes perform by regularly scheduling game days to simulate events in production. This will help you understand when improvements can be made and can help develop organizational experience in dealing with events. Next, we'll talk more about each of the 5 pillars of the well-architected framework. Creating a software system is a lot like constructing a building. If the foundation is not solid, structural problems can undermine the integrity and function of the building. When architecting technology solutions, if you neglect the 5 pillars of operational excellence, security, reliability, performance efficiency, and cost optimization, it can become challenging to build a system that delivers on your expectations and requirements. Incorporating these pillars into your architecture will help you produce stable and efficient systems. This will allow you to focus on the other aspects of design, such as functional requirements. And with that said, the first pillar we're going to talk about is operational excellence. The operational excellence pillar includes the ability to run and monitor systems to deliver business value and to continually improve supporting processes and procedures. The operational excellence pillar provides an overview of design principles, best practices, and questions. There are 6 design principles for operational excellence in the cloud. The first is performing operations as code. In the cloud, you can apply the same engineering discipline that you use for application code to your entire environment. You can define your entire workload as code and update it with code. You can script your operations procedures and automate their execution by triggering them in response to events. By performing operations as code, you limit human error and enable consistent responses to events. You should also annotate your documentation. In an on-premises environment, documentation is created by hand, used by people, and hard to keep in sync with the pace of change. In the cloud, you can automate the creation of annotated documentation after every build. Annotated documentation can be used by people and systems. You should use annotations as an input to your operations code. Next, you should make frequent, small, reversible changes. Design workloads to allow components to be updated regularly. Make changes in small increments that can be reversed if they fail. Additionally, you should refine operations procedures frequently. As you use operations procedures, look for opportunities to improve them. As you evolve your workload, evolve your procedures appropriately. Set up regular game days to review and validate that all procedures are effective and that teams are familiar with them. You should also anticipate failure. Perform pre-mortem exercises to identify potential sources of failure so that they can be removed or mitigated. Test your failure scenarios and validate your understanding of their impact. You should also test your response procedures to ensure that they are effective and that teams are familiar with their execution. Set up regular game days to test workloads and team responses to simulated events. And finally, you should learn from all operational failures and drive improvement through lessons learned from all operational events and failures. Share what is learned across teams and through the entire organization. There are also 3 best practice definitions you should be aware of. You should prepare, you should operate, and you should evolve. Operations teams need to understand their business and customer needs so they can effectively and efficiently support business outcomes. Operations creates and uses procedures to respond to operational events and validates their effectiveness to support business needs. Operations collects metrics that are used to measure the achievement of desired business outcomes. Everything continues to changes: your business context, business priorities, customer needs, and anything else. It's important to design operations to support evolution over time in response to change and to incorporate lessons learned through their performance. There are also several best practices to keep in mind, and the first is preparation. Effective preparation is required to drive operational excellence. Business success is enabled by shared goals and understanding across the business, development, and operations. Common standards simplify workload design and management, enabling operational success. Design workflows with mechanisms to monitor and gain insight into application, platform, and infrastructure components, as well as customer experience and behavior. You should create mechanisms to validate that workloads or changes are ready to be moved into production and supported by operations. Operational readiness is validated through checklists to ensure a workload meets defined standards and that required procedures are adequately captured in runbooks and playbooks. Validate that there are sufficient trained personnel to effectively support the workload. Prior to transition, test responses to operational events and failures. You should also practice responses in supported environments through failure injection and game day events. AWS enables operations as code in the cloud and the ability to safely experiment, develop operations procedures, and practice failure. Using AWS CloudFormation enables you to have consistent, templated, sandbox development, test, and production environments with increasing levels of operations control. AWS enables visibility into your workloads at all layers through various log collection and monitoring features. You should implement the minimum number of architecture standards for your workloads. You should balance the cost to implement a standard against the benefit to the workload and the burden upon operations. Reduce the number of supported standards to reduce the chance that lower than acceptable standards will be applied by error. Operations personnel are often constrained resources. You should also invest in scripting operations activities to maximize the productivity of operations personnel, minimize error rates, and enable automated responses. Adopt deployment practices that take advantage of the elasticity of the cloud to facilitate pre-deployment of systems for faster implementations. The next best practice is operation. Successful operation of a workload is measured by the achievement of business and customer outcomes. You should define expected outcomes, determine how success will be measured, and identify the workload and operations metrics that will be used in those calculations to determine if operations are successful. Consider that operational health includes both the health of the workload and the health and success of the operations acting upon the workload. For example, deployment and incident response. You should establish baselines from which improvements or degradation of operations will be identified, collect and analyze your metrics, and then validate your understanding of operations success and how it changes over time. Use collected metrics to determine if you are satisfying customer and business needs, and identify areas for improvement. Efficient and effective management of operational events is required to achieve operational excellence. This applies to both planned and unplanned operational events. You should use established runbooks for well-understood events and use playbooks to aid in the resolution of other events. Prioritize responses to events based on their business and customer impact. You should also ensure that if an alert is raised in response to an event, there is an associated process to be executed with a specifically identified owner. Define in advance the personnel required to resolve an event and include escalation triggers to engage additional personnel as it becomes necessary. Identify and engage individuals with the authority to decide on courses of action where there will be a business impact from an event response not previously addressed. Communicate the operational status of workloads through dashboards and notifications that are tailored to the target audience, for example, customer, business, developers, and operations audiences, so that they may take appropriate action, so that their expectations are managed, and so they are informed when normal operations resume. You should determine the root cause of unplanned events and unexpected impacts from planned events. This information will be used to update your procedures to mitigate future occurrence of events. Communicate root cause with affected communities as appropriate. In AWS, you can generate dashboard views of your metrics collected from workloads and natively from AWS. You can leverage CloudWatch or third-party applications to aggregate and present business, workload, and operations level views of operations activities. AWS X-Ray, CloudWatch, CloudTrail, and VPC flow logs all enable the identification of workload issues in support of root cause analysis and remediation. Another best practice is evolution. Evolution of operations is required to sustain operational excellence. You should dedicate work cycles to making continuous incremental improvements. You should also regularly evaluate and prioritize opportunities for improvement, including both the workload and operations procedures. You should include feedback loops within your procedures to rapidly identify areas for improvement and capture learnings from the execution of operations. You should also share lessons learned across teams to share the benefits of those lessons, analyze trends within lessons learned, and perform cross-team retrospective analysis of operations metrics to identify opportunities and methods for improvement. You should implement changes intended to bring about improvement and evaluate the results to determine success. With AWS developer tools, you can implement continuous delivery, build, test, and deployment activities that work with a variety of source code, build, testing, and deployment tools from AWS and third parties. The results of deployment activities can be used to identify opportunities for improvement for both deploying and development. You can perform analytics on your metrics data, integrating data from your operations and deployment activities to enable analysis of the impact of those activities against business and customer outcomes. This data can be leveraged in cross-team retrospective analysis to identify opportunities and methods for improvement. The AWS service that's most essential to operational excellence is CloudFormation, which you can use to create templates based on best practices. And we've covered CloudFormation in other videos, but just know that CloudFormation will absolutely help to unify your processes and contribute to your operational excellence. For your preparation best practice, AWS Config and AWS Config rules can be used to create standards for workloads and determine if environments are compliant with those standards before being put into production. For your operation best practice, CloudWatch will allow you to monitor the operational health of a workload. And finally, for evolution, Amazon Elasticsearch service allows you to analyze your log data to gain actionable insights quickly and securely. The security pillar includes the ability to protect information, systems, and assets while delivering business value through risk assessments and mitigation strategies. The security pillar provides an overview of design principles, best practices, and questions. There are a few design principles to keep in mind for the security pillar of the well-architected framework, and the first is implementing a strong identity foundation. You should implement the principle of least privilege and enforce separation of duties with appropriate authorization for each interaction with your AWS resources. You should also centralize privilege management and reduce or even eliminate reliance on long-term credentials. You should also enable traceability. You should monitor, alert, and audit actions and changes to your environment in real time. Integrate logs and metrics with systems to automatically respond and take action. You should also apply security at all layers. Rather than just focusing on protection of a single outer layer, apply a defense in-depth approach with other security controls. Next, you should automate security practices. Automated software-based security mechanisms improve your ability to securely scale more rapidly and cost-effectively. You should create secure architectures, including the implementation of controls that are defined and managed as code in version-controlled templates. You should protect data in transit and at rest. You should classify your data into sensitivity levels and use mechanisms such as encryption, tokenization, and access control where appropriate. Wherever possible, you should also keep people away from your data and create mechanisms and tools to reduce or eliminate the need for direct access or manual processing of data. This reduces the risk of loss or modification and human error when handling sensitive data. And finally, you should prepare for security events. By that I mean you should prepare for an incident by having an incident management process that aligns to your organizational requirements, and run incident response simulations and use tools with automation to increase your speed for detection, investigation, and recovery. There are also several best practices you should be aware of. Before you architect any system, you need to put in place practices that influence security. You will want to control who can do what. In addition, you want to be able to identify security incidents, protect your systems and services, and maintain the confidentiality and integrity of data through data protection. You should have a well-defined and practiced process for responding to security incidents. These tools and techniques are important because they support objectives such as preventing financial loss or complying with regulatory obligations. The AWS Shared Responsibility model that we covered in a previous video enables organizations that adopt the cloud to achieve their security and compliance goals. Because AWS physically secures the infrastructure that supports our cloud services, as an AWS customer, you can focus on using services to accomplish your goals. The first best practice for security is identity and access management. Identity and access management are key parts of an information security program, ensuring that only authorized and authenticated users are able to access your resources, and only in a manner that you intend. For example, you should define principles, that is, users, groups, services, and roles that take action in your account, build out policies aligned with these principles, and implement strong credential management. These privilege management elements form the core of authentication and authorization. In AWS, privilege management is primarily supported by the AWS Identity and Access Management service. You should apply granular policies which assign permissions to a user, group, role, or resource. You also have the ability to require strong password practices such as complexity level, avoiding reuse, and enforcing multi-factor authentication. You can use federation with your existing directory service as well. For workloads that require systems to have access to AWS, IAM enables secure access through roles, instance profiles, identity federation, and temporary credentials. Credentials must not be shared between any user or system. User access should be granted using a least privilege approach with best practices including password requirements and multi-factor authentication enforced. Programming access, including API calls to AWS services, should be performed using temporary and limited privilege credentials such as those issued by the AWS Security Token Service. The next best practice is detective controls. You can use detective controls to identify a potential security threat or incident. They are an essential part of governance frameworks and can be used to support a quality process, a legal or compliance obligation, and for threat identification and response efforts. There are different types of detective controls. For example, conducting an inventory of assets and their detailed attributes promotes more effective decision-making to help establish operational baselines. You can also use internal auditing and examination of controls related to information systems to ensure that practices meet policies and requirements and that you have set the correct automated alerting notifications based on defined conditions. These controls are important reactive factors that can help your organization identify and understand the scope of anomalous activity. In AWS, you can implement detective controls by processing logs, events, and monitoring that allows for auditing, automated analysis, and alarming. CloudTrail, AWS API calls, and CloudWatch all provide monitoring of metrics with alarming, and AWS Config provides configuration history. GuardDuty is a managed threat detection service that continuously monitors for malicious or unauthorized behavior to help you protect your AWS account and workloads. Log management is important to a well-architected design for reasons ranging from security or forensics to regulatory or legal requirements. It's critical that you analyze logs and respond to them so that you can identify potential security incidents. AWS provides functionality that makes log management easier to implement by giving you the ability to define a data retention lifecycle or define where data will be preserved, archived, or eventually deleted. This makes predictable and reliable data handling simpler, and more cost-effective. Another best practice is infrastructure protection. Infrastructure protection encompasses control methodologies such as defense in depth necessary to meet best practices and organizational or regulatory obligations. Use of these methodologies is critical for successful, ongoing operations in either the cloud or on-premises. In AWS, you can implement stateful and stateless packet inspection either by using AWS native technologies or by using partner products and services available through the AWS Marketplace. You should use Amazon Virtual Private Cloud, which we've covered in depth, to create a private, secure, and scalable environment in which you can define your topology, including gateways, routing tables, and public and private subnets. Multiple layers of defense are advisable in any type of environment. In the case of infrastructure protection, many of the concepts and methods are valid across cloud and on-premises models. Enforcing boundary protection, monitoring points of ingress and egress, and comprehensive logging, monitoring, and alerting are all essential to an effective information security plan. AWS customers are able to tailor or harden the configuration of an Amazon Elastic Compute Cloud, Amazon EC2 Container Service, or AWS Elastic Beanstalk instance, all of which we've covered in this course, and persist this configuration to an immutable AMI. Then, whether triggered by autoscaling or launched manually, all new virtual servers launched with this AMI receive the hardened configuration. You should also consider data protection, and before architecting any system, foundational practices that influence security should be in place. For example, data classification provides a way to categorize organizational data based on levels of sensitivity, and encryption protects data by way of rendering it unintelligible to unauthorized access. These tools and techniques are important because they support objectives such as preventing financial loss or complying with regulatory obligations. AWS provides multiple means for encrypting data at rest and in transit. And the final best practice for security is incident response. Even with extremely mature and preventive and detective controls, Your organization should still put processes in place to respond to and mitigate the potential impact of security incidents. The architecture of your workload strongly affects the ability of your teams to operate effectively during an incident, to isolate or contain systems, and to restore operations to a known good state. Putting in place the tools and access ahead of a security incident, then routinely practicing incident response through game days, will help you ensure that your architecture can accommodate timely investigation and recovery. You should ensure that you have a way to quickly grant access for your InfoSec team and automate the isolation of instances as well as the capturing of data and state for forensics. There are a few key AWS services that will help you with the security part of your well-architected framework. The most important is, of course, AWS Identity and Access Management, which we've covered in this course, and which will allow you to securely control access to AWS services and resources for your users. There are also detective controls like CloudTrail, which will help you record API calls. AWS Config will also provide a detailed inventory of your AWS resources and configuration. There's also Amazon GuardDuty, which is a managed threat detection service that continually monitors for malicious or unauthorized behavior. And finally, CloudWatch is, of course, a monitoring service for AWS resources. Once again, for infrastructure protection, you have Amazon VPC, which enables you to launch AWS resources into a virtual network that you've defined. There's also Amazon CloudFront, which is a global content delivery network that securely delivers data, videos, and applications, and APIs to your viewers, which integrates with AWS Shield for DDoS mitigation. For data protection, you can use services such as load balancing, Elastic Block Store, S3, and RDS, which all include encryption capabilities to protect your data in transit and at rest. And then finally, for incident response, Identity and Access Management should be used to grant appropriate authorization to incident response teams and response tools. AWS CloudFormation can be used to create a trusted environment or clean room for conducting investigations. CloudWatch events also allow you to create rules that trigger automated responses, including Lambda. And that'll wrap it up for this first part covering the well-architected framework. If all of that makes sense, then feel free to move on.